So in this video we're going to be adding and subtracting polynomials. So basically we're going to be looking at polynomial expressions and trying to figure out how they work and if they're equivalent to each other. And we'll just start with an example. Say we have two functions. Function 1, and that is negative 5t squared plus 100t plus 1000. Let's say I have another one. Another function, and this one is negative 5t squared plus 75t plus 1200. And say we find the difference between these two. Say we want to do this. F of x is equal to f1 of x minus f2 of x. So that minus that. Now if we were to write that out, that would be negative 5t squared plus 100t plus 1000 minus the polynomial of negative 5t squared plus 75t plus 1200. And this could easily be simplified down to, if you were to open the brackets, you'd be adding these three. Or you can even just look at this here and just work downwards. Like, you know how we used to do substitution or elimination. So these will cancel out, and you're left with adding these two. 175, no, hold on, yeah, 175t, because I'm subtracting. Let's open the brackets and do this one step at a time. So we have a subtraction here. So we're going to do plus 5t squared minus 75t minus 1200. So let's simplify that. These two get cancelled. 100 minus 75 is 25t. 1000 minus 1200 is 200. So now I have this function. I'm going to call this g of t. G is a function of t. And now I also have this ginormous function here. So I have f of t and 2t, f of t and g of t. So that is our function simplified when I open the brackets here. But we can also say that this function here on a completely different problem is also equal to now can this function here be equal to this function here? And the answer is that these two functions are not equivalent. What you need to understand about the two functions, one being simplified step by step and the other one being simplified by skipping many steps. You need to understand that polynomials behave like numbers. For any value of the variable, the result is a number. So whatever this is, it's going to be a number here. So if you were to do subtraction or even like elimination, then you can see that adding the opposite of the second expression, you can collect like terms and end up with this. So in our problem, we can say that this secondary function here is not equivalent to our initial function. So let's try another example of like when we look at equivalence between expressions. So let's do something like this. So this is our first function. And now let's do this is our second function. Now I want to see if this is these two functions are equivalent or not. And the way you do that is simply by plugging in some numbers. So let's just put in x equals 0, y equals 0, z equals 1. And when you put these numbers into here, well, yeah, that's a very easy way to check. We can do 0 times 0, 0, which is 0. 0 times 1 plus 0 times 1. This will be 0, this will be 0, this will be 0. That is a big fat 0. But here, if you do 0 squared plus 0 squared plus 1 squared, you actually end up with 1. So you can say, therefore, these expressions are not equivalent. So, one thing you can always check if you have two different functions, say their lines y equals mx plus b. In two different forms, you have one here and two here. For these two, let's say that line is like that. For this expression, it could be like, say, y equals 10x plus 10, right? This could be y equals 10x plus 1. These two are in fact the same, but these two functions have to have the same graph, and that's how we can tell. And also, if I was to plug in like 1 into this, I get 1 plus 1 is 2, this is 20. If I put in 1 here, I get 1 times 10 plus 10, which is 20. But if I was to plug in like 10 times 10 is 100, plus 10 is 110. Let's do 10 here. 10 plus 1 is 11, times 10 is 111. And that is how we check for this video on adding and subtracting polynomials. This is really just to see how these numbers or these functions can change and how the equivalencies can be checked. So yeah, I hope this was not as confusing as it was to me. But yeah, maybe in the future we can come back to this and work more on it and clarify more things. But for now, I'll leave it at that, and I shall see you in the next one. Okay, so in this video, we're going to be learning how to, or we're going to be multiplying polynomials. So let's start with two functions. So now that I have these two functions, I want to multiply them. I want to find and that is exactly what it looks like when you imagine it in your sleep. And that's how we're going to go about doing this. So we can do this like in our previous videos we've actually done this, but here we're going to open this up using the distributive property. So we're going to do the -10 first into these three. So it's going to go in like and then it's going to go in like this, the 5. So let's write that out. So let's do these ones here. -10 into -5t squared, -10t into -5t squared. That's going to give me a positive number. T times t squared gives me t cubed. And then if I do that with that one, I should get -50 t squared. And then I should get 2.5 times 10 negative then simplify it to this. Let's do another one because these are fun. Let's say I have a cube or a rectangular prism. Oops, I guess I cut it off the page. But say I have a height of x plus 3 and a depth of x plus 2 and a length of x plus 1. Now I want to find the value which is equal to length times width times height. So I'm just going to multiply this. And yeah, let's take it from here. First, let's multiply these two. X squared plus 2x plus x, so plus 3x. So if you are confused, I multiplied that to that 2 and that to that 1. So I get 2x plus 1x is 3x plus 2. Now let's multiply this binomial into this trinomial. So now I have this 3 is going to multiply to this trinomial. This x is going to multiply into that trinomial. So I have x cubed plus 3x squared plus 2x plus 3x squared plus 9x plus 6. If I group the like terms, x cubed, I have 3x squared and 3x squared. That's going to give me 6x squared. And then I have 2x plus 9x, that's 11x. Then I have 6. And here is my formula for this rectangular prism for its volume. And that's a way we can use math to figure out or make expressions for things. Let's look at one more. Like if we wanted to do this the other way, let's say I wanted to multiply those two instead from the start, right? I could do v equals x plus 1 times, let's multiply those two, x squared plus 2x plus 3x, that would be 5x plus 2 times 3 is 6. If I was to multiply that, I can do, let's multiply the x inverse, x squared plus 5x squared plus 6x. And now let's multiply the 1 plus x squared plus 5x plus 6. This should be cubed, sorry. Again, let's do this. 5x squared plus this cube, the only one. 5x squared plus x squared is 6x squared. I have 6x plus 5x, that's 11x. And I have 6. Same. And yeah, let's do some more. Let's look at this. I have z, and they're all equal to 1. If I plug into 1 into all these, it's 2 times 1 plus 3 times 1 plus 4 times 1 squared. And that'll give me 2 plus 3, which is 5, plus 4, it's 9. 9 squared is 81. But here, if I plug in 1 into here, 4 times 1 squared plus 9 times 1 squared plus 16 times 1 squared. I'm left with 4 plus 9 plus 16, which is 49. And since this is not equal to that, we say that they're not equivalent. Another thing we could do is this side here is expanded, whereas this side is factored. What we can do is expand this and see if it actually equals this in the expanded form. So that trinomial being multiplied by itself is the equivalent of saying one step at a time. Let's do the 2x first. I'm going to multiply this guy by those 3. So 2x times 2x, that's, I already messed up. Starting on 4x squared plus 2x times 3y is equal to 6xy. 2 times 2x times 4z is equal to, that's that one. Now let's move on to this one. 3y times 2x is going to be 3y times 3y is going to be 3y times 4z is going to be 12yz. And now I'm going to do this last one, 4z. 4z times 2x is going to be 8xz. 4z times 3y is going to be 12yz. 4z times 4z is going to be 16z squared. And now let's simplify this. We have a 4x squared. And we have 6xy plus 6xy. That'll give me 12xy. And now I also have, where do I have xz, 8xz. I have an 8xz plus an 8xz here. That'll give me 16xz. I also have a 9y squared plus 812 plus 12yz plus 24yz and a 16z squared. So now we can see that this expanded form is not equal to this, and I can say therefore not equivalent at all. And that's that. So that has been some multiplying of some binomials or trinomials, polynomials overall. If we take it one step at a time and be vigilant and go through this tedious process, we shouldn't have a problem. So yeah, that's all for this video. I'll see you in the next one. Okay, so in this video we're going to be factoring polynomials. So let's start with a function. this multiplied by 3 is that, and that multiplied by 3 is that. So from the first bracket I can factor out, let's see, 3n squared. Actually, sorry, just n squared. And I'm left with n plus 3. If I take n out, n squared from n cubed, I'm left with n. If I take n squared out from 3n squared, I'm left with 3. And similarly, if I took out a common factor from here, which is 2, obviously, I'm left with n plus 3. And because I'm left with the exact same thing, I can write this out like and then n squared plus 2. And that is how I can factor by grouping. And now let's look at some quadratics. Let's do like a quick refresher. Remember, we want two numbers that multiply to the third term and add up to the second term. And remember the sign of the third term. If it's negative, it means I have a positive multiplying by a negative. So that's the first thing. And it means, well, the negative means that it's two different signs, positive or negative, negative or positive. But to figure out which one or how they multiply or add up, I know that they add up to the middle number, which is if that's also a negative. I know that the bigger number is going to be negative because, let's put it like this, because when you add these two numbers up, you're still in the negative. So in this case, two numbers that add up to 30. I mean, you can do 1 and 30, 2 and 15, 3 and 10, 4, not exactly, but 5 and 6. And the ones that add up to that, to a negative 1, in this case, the only ones off by 1 are these ones. And my bigger number is going to be negative, so I'm going to have x minus 6, x plus 5. So that's what I'm left with. So, let's do another one. Let's do 18x squared minus 50. And let's see where we can take things out. So one of the first things I see, a common denominator between these two, is a 2. I'm left with 9x squared minus 25. And now I can see that 3 squared gives me 9 and 5 squared gives me 5. So there is that rule that we learned in our previous year's lesson. X squared minus y squared equals, well, let me write an easier way. And x squared minus y squared is equal to, well, I forget the exact thing. I'll find it and I'll put it in somewhere. But this eventually will become 3x plus 5, 3x minus understanding this, we'll be able to look at something like that and quickly go down into that. So that's something important to have. Let's continue. Let's do another one. Let's do so. How can we factor that? And there are several ways to go about this, but in this case, we're going to do something called like when we look at this, we see that we don't have any common factors. So what we can do is take this middle term and split it. So I know that 5x minus 6x is equal to negative x. So instead of writing that, I'm just gonna write it. And the logic behind knowing when to do this is when, like, you know, you don't have any common factors here, or this doesn't fulfill any identities, then I can do something like this, and then I can group. Again, I can do a 5x, and I'm left with 2x plus 1, and then what can I take out from here? Let's see, negative 3. So if I take out a negative 3, I'm left with 2x plus 1. And again, I'm left with 5x minus 3. And there we go. Now let's do another one. Let's do 9x squared. This one, let's see how we can approach this. I believe this looks like a perfect square. Again, notice the squares always. In the last one we had the, what was it? The 9x squared minus 25, which became x plus y, x minus y. If you remember from our previous year video on perfect squares, there's another rule in which it is x plus y. Oh, let's do an x plus y. Sorry, I believe it was x plus y times x plus y gives me x squared plus 2xy plus y squared. So recognizing that this is actually 3x, and then our y is actually 5. Right, and if I was to expand this, 3 times 3x, 9x squared plus 15x plus 15x plus 25. Yep, and I end up with that. So that is my answer. Well, actually 3x plus 5 squared. And yeah, we can continue with something maybe a bit more fun. let's prove. I know that when I have x plus 1 here, nothing to factor out there, but here if I factor out x squared, I'm left with x plus 1. It looks scary in the beginning, but look how simple it got. Let's do one more. Let's go with something like this. And right off the bat, let's see what I can do. That doesn't have any common things over there, but I can see this. I know that is one of these. Yeah, that'll give me, one of those. X squared minus 2xy minus y squared, or plus y squared. Negatives gives me a positive product. So that should give me, by that logic, x. And then my y in this case is a 3. And now I'm left with 4y squared. But technically, this is that is actually 2y squared. So by the same logic that I used here, let's see if I can do the exact same thing again using difference of squares. If by this logic I do, I should be able to refactor this in. No, hold on. It was actually this one. So that so in this case, this entire term is x, and this entire term is y. So if I want to put into this, I can write x, which is x minus 3 plus y. And then the same, x minus 3 minus 2y. And that is how we do difference of squares. So yeah, that has been a little bit of polynomial factoring, and I hope picked up something from it, and yeah, I shall see you in the next one. Okay, so in this video we're going to be simplifying rational functions, so let's start with the function. And this function, we are going to simplify it so let's see what we can do with this. Let's try simplifying either the numerator or denominator first, or we can actually do it in parallel. let's look at the numerator. What can I factor out from the top? 3n squared. Right. And from the denominator, I can see that I can factor out a 4n, which will leave me with if I take out 4n, I'm left with 2n squared minus 6n plus 1. Yeah. And now I'm pretty sure I could factor out that. Oh, sorry, no. This is. If I factor out a 4, I'm left with 3 here. My mistake. Now I can factor this out. So, this is very straightforward now. Factoring this out into 2n minus 1 and n minus 1. 2n squared minus n minus 2n. And yeah, that's that. The full way to do this in steps would have been 2n squared minus 2n minus n plus 1. I believe, yeah. No, hold on. Minus. Nope, sorry. Other way around. 2n squared minus n minus 2n plus 1. And then if I factor out a negative 1 from there, yeah, so 2n squared minus n minus 2n plus 1, factoring out an n, so I'm left with 2n minus 1, and then from here I can factor out a negative 1, and I'm left with 2n minus 1 minus 1 and minus 1. That's what you get here. So now I see something clearly in this function, that I have an n minus 1 in the numerator and an n minus 1 in the denominator. These will cancel out, and I'm left with 3n squared over 4n times 2n minus 1. And there we have it. Let's try doing another one. Maybe not in green. Let's try blue. Let's do so. Let's look at this. Let's see if we can factor out something in both the numerator and denominator to cancel out. I know that I can do this very quickly in my head and write out the final answer, but if we were to do it step by step, I want to basically factor out everything that I can cancel and then cross them out. So I know that something that's common here is going to be a 6 from the numerator. I'm left with 5. I know that I have a common of x4 and a common of 1y. So I'm left with y squared here. And in the denominator, I Let's look at another one. Let's do maybe red. Let's do this one. X squared plus 7x minus 8 over 2 minus 2x. So from the numerator, I can break this down into two numbers that multiply to negative 8 but add up to that. So I have 1 and 8 that's going to add up to that. So I'll do 8 minus 1. So that's x minus 1, x plus 8. And then in the denominator, I can take out a 2. From here, so I'm left 1 minus 2, 1 minus x, sorry. So I notice one thing. If I take out a negative sign from this right here, I can actually flip the signs inside of it. And I'm left with 1 minus x on the numerator and denominator. And I'm left with negative. Which is also, negative x minus 8 over 2. Maybe we can do one last one. Let's do this one. So let's take out a 4 from the numerator. Let's do that. So this is also just like writing from before. We have x. Remember that? So let's do that. Let's do something with the denominator first. The denominator looks like it's a two numbers that add up to that. Yeah, I think we can do two numbers that add up to this but multiply to that. Let's see if we can do, because this is technically it's a 1. So if we do add something like x plus y times x minus y, because that's a negative, but this one's going to be positive, so I can do that. 3 times 2, it'll give me a 6. A negative 6. Negative 2y times positive 3y will give me a negative 6y squared. Plus 3xy minus 2xy will give me that. So that should give me and this I can rewrite as the difference of squares formula. It should give me and that will put me here. And now, boom, we have a common term in the numerator and denominator. And now I can write it out as 4 times x minus 2y over x plus 3y. And that's that. That is how So in this video we're going to be multiplying and dividing rational expressions. So let's start with something 6x squared over 5xy times 15x y cubed times x 8xy to the 4. Now, as we remember multiplying fractions, you just go straight across. And so 6 times 5 should give me 90. And then I can add the exponents, so x cubed, and then I have a y cubed. Same with here. 5 times 8 is 40. X to the 1 and x to the 1 will give me x to the 2. Y to the 1 and y to the 4 will give me y to the 5. So now we remember how to factor things out. So I know that 90 over 40 is the same as 9 over 4. And then x to the 3 divided by x to the 2, the exponents will subtract, so I'm left with x to the 1 in the numerator, and then so that'll cancel. I'm left with x, these two will cancel. On the bottom, 3 minus 5 will give me negative 2. So that's basically like saying that, we could have put negative 2 like this, 9x y negative 2 over 4. But this negative 2 just means it's a 1 over y to the 2. So same as this. So yeah, that has been a very simple one. Let's do something a bit more fun. Yep, this one looks fun. So, right off the bat, let's start doing some factoring. I can factor this and that. I know that that's my difference of squares, so that'll be x minus 2, x plus 2, x plus 6, x plus 6, that's just x plus 6 squared, times, let's factor that out, two numbers that multiply to 18 but add up to 9, same sign. That should be 3 times 6, x plus 3, x plus 6 divided by 2 times, see this 2, x minus 2, if I take out the negative sign from the bracket and put it in front of there, I'm left with x plus 2. Sorry, no, x minus 2. Now, I can start cancelling things out. So if I put all this over the same bracket, or the same fraction, now I have in the denominator x minus 2 in the numerator. Those are gone. Same with one of these x plus 6's. And now all I'm left with is that negative in the denominator with that. So I can bring the negative up here. So I can write negative x plus 2. I'm left with this one, x plus 3. And denominator. The 2 is still there. X plus 6. let's do another one. Maybe one more. This one looks like it's gonna be fun. Let's do this one. Let's do. Oh, I want to blow this one. Let's go. 21p minus 3p squared over 16p plus 4p squared divided by 14 minus 9p plus p squared 12 plus 7p plus p squared. So, now that we have a division sign, that means nothing. All we do is flip the sign. Okay? And then these I'm going to rewrite it in ways that I like. I like putting my higher numbers on one side. So, let's factor out a 3p from here first. Let's do 3p, because I know 21 and 3 have a common factor of 3, so that'll give me 7 minus p. And then for this one, I also have a 4 and a p in both, so I can do and now we're going to flip this around to multiply. So in the numerator, I'm going to have this, but if I was to factor that ahead of time, that's the same as writing this p squared plus 7p plus 12. So two numbers that multiply to 12 and add up to that, that's 3 and 4. So I can write that out. But if I write it out like that, well, let's just write it out like that, see what happens. 4 plus p, 3 plus p. And the same goes for the numerator. That's p squared minus 9p plus 14. So that'll give me two numbers, two negative numbers. I'm going to say negative 2 and negative 7, p and p. Yeah, this should work. 7 minus p, 2 minus p. And right away I can see so many things to cancel. 4 plus p, 4 plus p, 7 minus p, 7 minus p. And so what does that leave me with in the numerator? Oh, I have this p here and that p there. So now I'm left with 3 in the numerator with this 3 plus p. And denominator I have a 4 and a 2 minus p. And yeah, that's all it was. Simple as that. Just factoring. When you can factor them, then you can like easily just start canceling them out in the numerator and denominators. But yeah, that's been like a common theme here, that we just kept repeating and repeating. And I hope this was helpful in some way. And in the future videos, we might get into more complex ones. But yeah, I hope you enjoyed that, and I shall see you in the next one. Okay, so in this video we're going to be adding and subtracting rational expressions. So, jumping off of what we've been doing so far. We've been simplifying, multiplying, dividing expressions. So now I'm going to take this and add in to all the, I'm going to take these three terms and turn it into one simple term, or like group and everything. You'll see what we do. So as you can see, we can treat these like fractions. Usually when we add fractions like 1 over 2 plus 1 over 3 plus 1 over 4, we try to find a common denominator between them. And once we have the common denominator, then we can turn it into one simple term. So we're going to do the same here. And we're going to start by finding a common term between these three. And so we know that we have numbers in front of each, like a real value between each one. So let's try to find a common multiple of these three values. So let's do the largest possible number between these, the smallest number that all three of these multiply to. So I know that, let's see, I can't do 12. Let's try 8 plus 8 equals 16. That doesn't go into 16. But 24. So this can multiply by 3 into 24. This can multiply by my math is killing me right now, 6, and this can multiply into 4. So one other thing, we have this x in the denominator. So the lowest common multiple I can do for x in terms of the variable is going to be x cubed. And you'll see why. So this fraction here, I can multiply by 4 over 4, which is basically multiplying it by 1. This middle one I can multiply in order to get, well, this is going to be my lowest common multiple. Let's say lowest common multiple. Now if I want this middle term to become this, the denominator to become that, I have to multiply the denominator by 6x. Because 6 times 4 is going to give 24. X times, wait, I need an x squared to give me x cubed. 6x squared. 6x squared divided by 6x squared. And then this one I can multiply by 3x. That'll give me 24x cubed. So when this multiplies by that, I should get 9x over 24x cubed plus 6x squared over 20x cubed minus 20 over 24x cubed. And now I can put all of them over the same denominator. And there you go. That was much more simpler than this original problem looked. Let's do another one. Something a little more challenging. Let's do 2n plus 1 times, no, sorry. Let's do minus 3. So let's say I have this problem now. Our lowest common multiplier, or common factor, or denominator, sorry. Our lowest common denominator this side by that, by this, or cross multiplication. It's like we're multiplying by 1. And then this side we're going to multiply it by 2 n plus 1. And we already had like n minus 3 there. And now this can all go under one common denominator. So it's going to be plus and there we go. Now we can actually start simplifying this by expanding these brackets. So now we can do, we have 3 3n squared as this multiplies in there, and that's going to multiply in there minus 9n plus 8n plus 4. And as you can see, we can group these terms and put them together. So we're gonna have 3n squared minus negative 9 plus 8. It's going to be n, which is negative 1 plus 4. And that is my final answer. So we went from this down to this. And yeah, it seems like we're just doing algebra, expanding and simplifying. Let's do one a little bit more complex. Let's do this one. 2t over t squared minus 1 minus t plus 2 over t squared plus 3t minus 4. This is going to be interesting. So, here I could just cross multiply and simplify. But if I wanted to save myself trouble, I know that this is a difference of squares. T squared minus 1 squared. So that'll give me t minus 1, t plus 1. That's what this is. And this one I can also factor two numbers that multiply to negative 4 and add up to positive 3. That's t plus 4, t minus 1. So I can rewrite this as 2t over t minus 1, t minus, or t plus 1, subtract t plus 2 over simplify. So let's do this. 2t into that. 2t squared plus 8t, which is that one. Now, when I open this up, so these are going to be -1 times whatever this is. So I know t times t is going to be t squared, but I have the negative in front. So I'm going to put t minus t, and then minus 2t, because of this negative. And then I have 2 times 1, and then the multiplying by the negative, all over t plus 4, t minus 1, t plus 1. And now time to simplify. I got a t squared and a t squared. 2 minus 1, that's just t squared. And then I got 8t minus t minus 2t. So that'll give me 8 minus 1 minus 2. And then I'm just left with my 2. And that is my answer. If you ever are asked to find the restrictions on this, just understand that the denominator cannot be negative. So t in this bracket, t cannot be 1, because if it is 1, this will be 0, and the whole denominator will be 0. 0 times anything is 0. And this one, it cannot be -1, and t cannot be -4. So yeah, I hope that was helpful, intuitive, or educational to some extent. But yeah, that is all for this video on adding and subtracting rational expressions. And I'll see you in the next confusing video.